Okay, we're looking at covalent compounds and Lewis diagrams, and this video accompanies the activity that's in the module, so it shows you how to get the answers. So draw Lewis dot diagrams for atoms of each of the following elements. So fluorine, if you look up the periodic table, you will see that the atomic number of fluorine is 9. So in looking at electron configuration, we'd have 2 electrons in the first energy level and 7 in the second. And this 7 is what we want to represent in the Lewis dot diagram. So we've got fluorine, 1, 2, 3, 4, 5, 6, 7. So the dot diagram represents the outer electrons. And you can easily see that it needs one more electron to attain the configuration of the nearest noble gas, which in this case would be neon. So now phosphorus, look it up on the periodic table, and you will see that the atomic number is 15. So 2 electrons in the first energy level, 8 in the second filling it, that's 10, so we have 5 left in the third. So dot diagram, P, 1, 2, 3, 4, 5. Okay, so in this case, you can see that phosphorus would want 1, 2, 3 more electrons. Last one, silicon. So the atomic number of silicon is 14. So 2 electrons in the first energy level, 8 in the second, that's 10, so there's 4 left over. So that 4 is what we want to represent. So we write Si, 1, 2, 3, 4. The next question is draw Lewis dot diagrams for each of the following covalent compounds. So Cl2, so chlorine is atomic number 17. So it would have 2 electrons in the first energy level, 8 in the second, 7 in the third. So the 7 is what we're representing in the dot diagram. So I've got Cl, 1, 2, 3, 4, 5, 6, 7. So when you're drawing two or joining 2 chlorines, put that isolated electron in the middle, because it will share the other isolated electron of the other chlorine. Okay, and this is where your bond is forming. So that would be Cl, Cl. Okay, HCl, hydrogen, atomic number is 1, so it's just that. Cl we've already done. So if I have hydrogen with its 1 electron, it's going to join with chlorine, its isolated one in the middle to share with hydrogen, and then its other 6. Okay, so that would be, in terms of bonding, HCl. Next, silicon is represented up here. Oxygen has an atomic number of 8. So 2 electrons in the first energy level, 6 in the second. So oxygen is going to look like 1, 2, 3, 4, 5, 6. So what we're going to have to do here, because silicon needs 4, 1, 2, 3, 4, there's going to be some sharing happening. So I'll draw silicon in the middle with its 1, 2, 3, 4 electrons, and then I'll draw an oxygen either side. Oxygen is going to share 2 electrons, and then its other 4 be represented on the outside. Now, because it's sharing electrons here and here, that's forming a double bond. So that would be O double bond Si double bond O.